Hey everyone, Spring 2022, Computer Science 1, Computer Programming and Methods at College of Sequoias. We're going to get started on our fourth section. Let me share screen and go over to the module and we can look at it real quick. So in the fourth section, we're looking at conditionals. So I'll click on it real quick. And we're talking about the conditionals are the if else, and the switch statements. But to use them, we need to learn about the comparators or the comparison operators. We'll look at recursion at the end. It's worth checking out. Recursion is a little bit of the pain in the ass, but it's worth taking a look at. Let's see. So our control statements have to do with the if and else. And these are like the conditional things. So let's go through them in C++. So I opened a new file and what do we need? We need to include, what do I include here? I have a stream, no one's answering for me. Using namespace. STD. Oop. Maybe I'll throw a comment line in at the top. Notes 4A. Not 4A, we're doing all of 4 today. Then we have our main. And so let's just look at some ideas. I'm going to say, well, let's look at how the things compare. If I wanted to compare 5 versus 6, what do we think that'll do when I run that? Any ideas?
Not a clue.
Not a clue. Okay, so let's check it and try to figure out what's going on. It says 1.
So that
That's
would be
weird.
True.
1, it's true. That's exactly it. 1 for true. So this is comparing two outcomes or two values and showing whether it's true or not. So we can have a couple, and notice it didn't actually show what the text would have been. If I wanted to show the text, I would have had to do it as a string. Like that. But if I do that, I guess I need to include the string library, right? So let's add that in. So that's going on. Do the parentheses matter? Check. Well, I don't like it, but it might run. Let's see what happens. It does not like it. All right, so let's put it back in parentheses. I want to say this ran in my living room, which is funny. Either way, it's a little bit easier to read with it in parentheses, and it's not something you would type in, obviously. It's generally not something. It's okay. Christian's got it muted now. It's not something you would generally type in, like you wouldn't say is 5 less than 6 and a C out. That seems a little bit silly because you know whether it is or not, but you might be comparing two variables. We could also have the opposite. 5 is greater than 6. And what value should this show? Anyone
0.
remember the 0? 0 for false. Let's make sure that happens. We could check, see if they're equal. If I say 5 equals 6, look, it's already pissed off. So recall that the equal sign is the assignment operator. It sets the thing on the left to the value on the right. We want to use double equal sign. Ah, damn it. So I'll put in a second equal sign. Oh, insert keys on. I like a space in there. And that's also not true. So we should get a 1 and a couple zeros, maybe our C out in there. So a lot of these things aren't true. So we can also do like the greater than or equal to. If you want to do like greater than or equal to, or less than or equal to, the equivalent is doing the less sign and then the equal sign. And we'll see how that runs. So 5 is less than or equal to 6, but I can change that to a 6 is less than or equal to 6. And you should still say true because it's 6 does equal 6. So that's pretty handy. We've got the less than or equal to, the greater than or equal to, less than, greater than, we have exactly equal to, and then we have not equal to. So let me throw a variable in. I'm tired of typing 5 and 6. Just say int x equals 3. And why not? Int y equals, I don't know, 10. And now we'll say, does x equal y? And then I'll do the not equal to. The not equal to is the exclamation point. And it goes outside the parentheses thing of what you're testing. So exclamation point is the not symbol. And so x is less than 3 is less than 10, or 3 is not equal to 10. So this one, it's not equal to, or it's equal to, it says 3 equals 10, which is not true. This one should show a 0. The c equals y, x equals y line. What does not equal to show? So this was our, this over so we can see it. This was our x equals y line. This is our not x equals y line. And so the reason why is so not false means true in Boolean. So that's what's going on. It changed. So it's doing the opposite of. So how can we use this kind of stuff? Well, those are all the conditional things. Let's look at how we use them in control sections. Let's say I want to check to see if these values, let's say I want different responses based on what these are. So the first command we're going to learn is the if. You say if, and you put in parentheses what you're checking. If x is less than 5. I'm going to comment all these out because that gets a little distracting for what we're going for now. If X is less than 5, what do I want to happen? I'll see out. Yep, X was less than 5. And now let's just do the opposite. Or let's do one for Y. If Y is less than 5, let's do Y less than 5. Why not? See out. Yep. Y was less than 5 also. So what it's going to go through, and when we have these if statements, it checks to see if the following condition is true. In our case, let's see what happens when we run. It says that, yep, X was less than 5, but it doesn't say, yep, Y was less than 5. So it checks to see if the condition is true. And if it is true, it does what follows. If it's not true, it skips what follows. So let's put that in our lesson plan real quick. If it's true, it does what follows. If it's not true, it doesn't do it. So I'm going to change this around. I'm going to make this X is greater than 5. I'm going to say X is, or Y is greater than 5. So now the Y one should print, because now we've got that matching up. And yeah, Y was 10. So, oh, I got to change the words because that doesn't make any sense. So what if I wanted to do something else? Let's say we wanted to, I want Y to equal, I want Y to go up. Say Y equals Y plus 1. Why is it going back to the left? I wanted it to go to the right. And then I'll see out Y. Oh, I need that. So, of course that's going to work. So everything's working fine. Let's do this up here and put the same thing right here. I'll say X equals X plus 1 if it worked. And I'll say see out X equals X. And I want those to line up, and it keeps kicking it back. So I'm going to have them line up. It's saying X equals 4. And I just told it it only wanted to do what if it's true. X was 3. This is not true. So another thing to note, it only does the next line, not everything that follows. If I wanted to do everything that follows, I'll copy this and put it down below. And I'll put the if statement here. I wanted to have all of that to trigger, and I don't want the X to see out the X. You have to capture it in curly braces. Oh. There we go. So curly braces are what we use to group for the or everything in the control statement. Which is our if, and we'll see in a second else. And even switch, we'll see switch in a second too. So now if I run it, let's comment out that one, because that one doesn't work. It didn't work the way I wanted it to. So now if I run it, this one should run and nothing here should run. So yeah, it did. It did exactly what it's supposed to. So it ignored everything in the X group because X was not greater than 5, but it did everything in the Y group. In fact, did it skip everything? I don't know. Let's see out X afterwards. It didn't do the C outs. Did it do this line right here? The X equals X plus 1? Let's check it. No, it didn't. Kept X equals 3.
Did I miss somewhere where you're defining X and Y?
It was at the very top. I'll scroll up.
Oh, okay.
Let me move it down here where it's in this section. Okay, so you set some conditions and those can change. We can do whatever we want. We can also do something called the else statement. The else statement goes with the if statement. The else control statement goes with the if. Like a follow-up. Because you don't want to have to go if y is greater than 5, do one thing. If y is less than 5, do one thing. Because what if we have a whole bunch of categories? That kind of sucks. So we could go if x is greater than 5. I already have less. Let's do that. If x is less than 5. We know we got to use our curly braces. We'll say x equals, instead of saying x plus 1, I can do this. I don't know if I taught you guys this earlier. X plus plus is the equivalent of x equals x plus 1. It's a shortcut command. So I'll add 1 to x, and then I'll see out x. And then I can do else. Now I don't need to put the criteria in. The else is whatever this one isn't. So if this is true, then this will be the not true category. So I'll just get right to it. See out x was not less than 5. I could maybe add a little bit more into this one, make it sound a little bit better. See out x was 5, or x was less than 5. We will increment x by 1. And now we can run it and check it out. Let's put another little end line in there. Make some space on the screen. So x equals 3, x was less than 5. We will increment x by 1, x equals 4. So it's triggering the first group. If I change the sign, we can see what happens if we change the sign where it's the opposite. So I'll change the sign and we'll check it. And it said X was not less than 5. So it's like a switch, a toggle. Do one thing or do another thing. So I'm going to reset X to 3 real quick just by saying X equals 3. So we could do like a real long one. We could go if X equals 1, see out X equals 1. And then I could say if X equals 2, but I'm not. Well, yeah, let's do it. Since I'm going to do all 3 cases, X equals 1 equals 2, X equals 3. I'll do all 3 cases. Let me just copy this line. In fact, copy this again, do it down there. This would be a 2. And we'll check X equals 3. So I could do this. I think it looks a little bit better with spaces between them. And we'll see which one happens. Let's comment out all this good stuff. While we're teaching about it. So I just did the X equals 3. You also have the option of combining these with the else thing. And the reason why you might want to do it is because here, if the first one was true, like let's say if X equals 1 is true, and I'm going to do that, let's set it X equals 1 is true. So as it's going through the code, right now it's checking each thing. It's checking if X equals 1, and then it's going to do the code. If X equals 2, it's going to do the code. If X equals 3, then it's going to do the code. So that can, with enough stuff in there, it can slow it down. This is where the else shows up pretty good. We could say else, and I could put like a parentheses and.
What does the double equal sign mean again?
It means check to see if it does equal. A single equal sign sets it equal to it. Like if I did X equals 2, like I did right here, X equals 1, I changed the value to 1. X equals 1 is checking to see if it equals 1.
All right, cool. Thank you.
So
I could do, go ahead.
Sorry, so these, you don't actually need an else statement if you're just using another if statement after. It'll just flow from one to the other. Is that what we're?
It'll go from the one to, without the else, it does each one, but it's going to do them all. It's going to check each one. If you've got enough of them or there's a lot of calculations, it could add time to it.
Okay.
And we could do this process in here. I could put an else in here too. And I could move my if X equals 3 inside there.
So then it only does the trailing function if the first function fails.
Right. So what it's doing, in fact, I think some people like doing it on the same line like this. Right now, what it's going to do is go, okay, let's change it to 3. Or let's change it to 2. We already did 1 and 3. So right now, X equals 2. Let's see if we can read through the code. It's going to go through and it's going to check if X equals 1. It doesn't. So it's going to skip this step. It's going to go to the else. And it goes inside the else and goes, if X equals 2, X equals 2, yes. So it's going to see out X equals 2. And since this is an else right here, it's going to skip checking this entirely. So for X equal 2, this else section won't be checked. for true or false due to the else. So we run it, we should get the x equals 2. And we did, we got x equals 2. The way I set it up right here, this is called a nested if-else statement. Nested because they keep going inside, inside, inside. If I back this up, it looks even a little bit clearer. Delete that. And no, it automatically does it that way. Okay, so that's one way of doing it where it can save some time. I got some spaces in here. Another way of doing the same thing is, let me copy it. And before we do it, we'll change x to 3 again. Instead of doing else and putting the f in here, or the if in here, you can do else if x equals 2 right here. Move that right there. And just, I guess I need that one. And I could move the if x equals 3 up into this else. Let's see, tab back, that ends that one. Backspace. No, we'll have it there. And tab those back. And I don't need that bottom one, it's extra right now. That one's extra too. Nope, that one wasn't, that one is. There we go. So this is like the nested, is like the nested if else. Some programming languages have, I noticed I did another comment thing, that's funny. Some languages put those together and make else if one word. C++ does not. But this does the same thing as the nested one. So in the first loop, we had x set to 2 and it did that one. The second if set, we had x equal 3 and it did the C out for that one. And let's say x equals 5 now. And let's talk about switch. So switch is when you've got like a lot of cases or you want some stuff to go on. Let's look at the switch command. Switch, you tell it what variable you're checking inside the parentheses. And then we're going to have a bunch of different cases. So they're going to do the cases in order, and you kind of want to, I'll relate it to what we had before. Oh, it aligned case 1 to the left. I didn't think it was going to do that. Case 1, we'll do the C out. And I notice I don't need curly braces. I could do C out. Another one with, I don't need a curly brace for the C out set or the case set. Yep, I said 1. When you want a case 1 to stop, the next case would be case 2. And I'm going to show you what happens when we do them like this. But I'll go through and like copy and paste this for all of them. So case, yep, I said, or C out x equals 2. Yep, I said 2. And we'll do case equals 3 or case 3. And it's a semicolon, not a colon. I'm sorry, it's a colon, not a semicolon for cases. Change this one to there. And you know what? I'm tired of checking them after that. So I'm going to just do one more. I'm going to call it the default case. And, oh, that says C out X equals 31. C out X was not 1, 2, or 3. Oh, I'll do another line down there. Get over it. Oh, I got a lot of spaces down there. So this is the switch statement. What we have is a case for each of the X's I wanted to check. And then the last case is the default case. And you want it to be listed as default. It's a catch-all for everything else. Possible answer. So actually, let's start with the X equals 1 case before I do this. Let's put some end lines in there. Now showing switch. So the only bracket we needed was to start switch and to end switch. I've got case X equals 1, and it should go to case 1 and print this stuff out. Actually, let's go to case 2. I'm going to do case 2. I'm going to go to case 2, and let's see what happens when I run case 2. Look at that. It skipped case 1, but then so it skipped case 1, but then it showed all of case 2, and then it showed all of case 3, and then it did the default. So the one thing switch requires that the other ones don't is when you want to end it, you want to end each case with break.
So is it doing the analysis in the output right there? Is that what's?
What do you mean?
So you're assigning X equals 2. And then in case 2, you don't have anything actually comparing.
That's how switch works. What you're comparing is this right here. So case
Oh, okay.
2,
So
I'm glad you asked. I didn't really make that clear, did I? This is checking to see if the variable in the switch parentheses
is equal to that.
equals this value. That's what's going on there. That's a great question. I'm glad you asked. What the break does is break kicks you out of the entire control statement. When we get to looping structures, it does it in looping structures as well. But now when I do it, case X equals 2, if I run it, now it's just doing X equals 2. Yep, I said 2, and it stopped. It didn't do any more because we broke out of the control statement.
So it only breaks out of the control statement if it's true?
It only breaks out of the control statement if it hits a break command. In fact, since there's nothing following the default case, I don't need a break there. In fact, I'll show X equals 5. And maybe we should add in another C out of the end. That's it. That's not really it, but that's what we're going to say.
So the switch, it only enters the statement if it's true. it then performs the C outs that you have underneath that statement, and then the break kicks it back out to the end of the program.
Yes, it kicks it back out of the switch. So break takes you here. Anything after break should still happen. I'm sorry, anything after switch should still happen. And we can check that by having the break in there right there. So it went through, it got to the default case. You always want a default case. And it does this. This is kind of handy when you don't want to do a bunch of the if stuff. You just need to know how to read it. You do have to break after each one, but also, if you don't want it to break out of it, let's do something like this. Let's see. I'm going to, nope, go back. I'll just make a whole new section. And we'll set X equal to 1 here. And now case 1, I'm going to say X is less than 1. Less than or equal to 1. I'll get rid of the extra C out and I'll get rid of the break. In fact, I'm going to get rid of the breaks on all. I'm going to say X is less than 1. I can say X is less than or equal to 2. It is not checking for X is less than or equal to 2. All it's checking for to see is if this is equal to 2. So notice the C out and what I actually have there are different. Default case probably shouldn't say anything about it because we don't know what we're checking here. Could have been a letter or something like that. We don't know what's going on. This was the default case. So not having the breaks in there, check what happens. Let me add some more endos there. Make it a little bit easier to read. So when we did the case 1, case 2, case 3, we had X equal to 1, it's checking each case to see if it applies. And if it applies, it's doing it. Well, I'm sorry, it's doing everything after it. That was the wrong way to say it. It's not checking each one. Once it checks a case and sees that it works, it does everything after it. That's a better way of saying it. Once it finds a case that matches, it does everything after it in the switch statement until the end or it finds a break. So that was what was going on here. But it sounds kind of funny saying X is less than or equal to 1. Maybe you're trying to see if X is greater than a certain value. Maybe you wanted to show it. I don't know why you would, but you might want to. If you want to show each of these one at a time, it will show it. But you probably, if you were doing that and you just wanted to show all the cases, but not the default case, you would probably put a break in right there at the back, last one. So it can be handy. I don't use it all that much, but I have used it a couple times. It's when you want more than one thing to show. Let's see, what else can I teach you? Ooh. So that was the switch statements. Now I know red doesn't do this. This is called the conditional ternary operator.
Ooh.
It's a sweet name, right? So the way it works is I'm going to do this. C equals and I'm just I don't want to combine them all in one. Let me do it first this way. Let's say A equals 5. And we'll say and B equals 3. And what we're going to do is say if A is greater than B, then we do a question mark. And we might need to put this in parentheses, the A greater than B. We do a question mark. And then I'm going to do A, comma, or colon B. And I think the easiest way to show you what's happening here is just do them. So let me repeat the line and change the symbol to less than. So we got A equals 5, B equals 3. Why did it not do it?
There's no output stream.
Oh, you're right. Oh, wait, I got a better way of doing this. We'll do A plus plus, and I'll do B plus plus. And then we will C out A, C out B. And I think we'll start that, copy that above that, do that there, and we'll do it after. And I got a lot going on, so let's unpack this a little bit. So the first one, it should just say A equals 5, B equals 3. Let's see what happens with the other ones. And while we're looking at it, let's put the code where we can see it. So A equals 5, B equals 3 did the first one. Notice it did on the next line, it does A equals 6, B equals 3. Oh, I didn't do the plus plus thing here. Let me do this. And maybe I should reset it. A equals 6, B equals 5, or A equals. That's the only one I had to reset. Now I'll run it. So A equals 5, B equals 3, then it gets to this one, and it raised A by 1. And then when we reset it back to 5 and 3, when we did this one, it raised B by 1. So what it's doing is what comes before the parentheses. Not before the parentheses, before the question mark, is a conditional. And then after the question mark, if it's true, that's before the colon. If it's false, it's after the colon. So another way of doing that, maybe unpacking this to see what it looks like without it. Let's reset this one. B went up to 5. So another way of doing this is saying the exact same thing. If A is great, we start off with greater. If A is greater than B,
So
A
your
plus-
conditional, and then your true case, and then your false case.
yes.
Okay.
Oop, not the right bracket. Else B plus plus, and I need a colon there. So this is doing the same thing as that. And I'll show it again by just putting this down again at the bottom. So it raised A, but not B. Equals 6. So it's like an if or an else, but so it's a shortcut. Well, check this out. Let's do my C. I'm going to make an int C. And the way it works is like this. We're going to say C equals, and then it does this, does the comparator. Is A less than B? And then we'll do A colon B. And now we'll see out C. Notice I have not assigned C any value. Let's make C a default value. Let's give it a 0. Now look what happens when I do this one. Did I not say? Oh, I didn't add the C. Lame. Try that again. All that grand theatrics and nothing. Like, so with just like doing the if else statement, it does the if else. It determines what is true. It returns the whichever one is the true thing, the true area or the false area, whichever one it's supposed to return, it does that. But now it's assigning that value to C. Here, we would have to do that in here. I would have to say C equals A. Or C equals B in the one below it. So this one, this does the test and then assigns the outcome to C. That's pretty slick. So the handy way of reading like this in general, I'll copy it down below. This is kind of like if A is less, nope, I'll do it on the C one. Don't need a bunch of lines in here. So this one is saying if A is less than B, C equals A. Otherwise, C equals B. Or else, but otherwise sounds a little bit better in English language. So it's a lot to use, but it can be really handy. If and else are pretty solid. This one's a little trickier. The hardest part about this one, to be honest, is remembering how it works. But if we look at our lecture notes, where was it? I'm going to go back a section. Go back. And you look up, I'm on control structures on C++. It talks about the if, and it's got the if else and if else if. While loop, while is like a looping structure. We're gonna do loops later on. But it's got the switches there. Where's the conditional ternary? Son of a bitch. It's not on this state. It used to be. I'm sure that's where I saw it. Huh. Never mind. Let's just go back to the lesson. Put that back up in the background. So let's take a look at the running the lecture notes real quick. Actually, let me close that. I'm going to copy this and I'll just paste it in an announcement real quick. Actually, I need to get the whole thing. Control C, we'll come over to the announcements. I guess I need to leave student view. Part A of lecture for module 4. God, don't need all that extra space there. Now we'll go back to the modules and we'll look at 4A. Because it's a flow chart and it's not necessarily clear what's going on here. Well, let's see if I can get my Zoom open. And can I annotate? Nope.
So are we generating a random integer or are we prompting the user for a random integer?
So we're going to generate a random integer.
Okay.
We're going to ask the user for an input of an integer for y. So the boxes show what we're going to print to screen. So we're going to prompt the integer for a y. The diamonds show when the decision making has to happen. So we'll have a random x, they give us a y, and we're going to check how y relates to x. If y was less than x, if their input was less than the random number, we're going to say it's too low. If y was greater than the random number, we'll say it was too high. And if it's exactly equal to it, we'll say you got it. So let's put that in words in the game real quick and introduce some stuff. So I already saved that into the lecture notes. We'll include the IO stream. Oh. Lab for a starter. We need to do random numbers, we need the CTime library. I keep doing it. And we want to include also the C standard library. Did it again. Like can't hit the shift right key when I'm doing that last bracket. We'll be using namespace std. We'll start our main app. Oop, lowercase. Turn 0. All right, so we're doing this is like a guessing game. And so it was The instructions were generate a random number. See if I can have this on the screen at the same time as I'm. So we generate a random number. We ask the user for an integer. And then if we do some control statements, you see if they were too low, too high, or got it right. Printing out the results, printing it out. So that's kind of what's going on. You got to look at it and follow what's going on the screen. So we generate a random integer. The box says print out or ask the user for an input. The diamond says we're going to make a decision. We're going to check, is y less than an x or is y greater than an x? Depending on the outcome, we go down a branch. If y is less than x, we say too low, and then it points to the circle, which means done, end of program. Then it goes, well, if y is greater than or equal to x, notice it's got the equal sign. Now it gets to another decision. Is y equal to x or is y not equal to x? If y equals x, it prints out, you got it right. If it's not equal to x and it's not less than x down this branch, it must be the greater than one, right? So it goes down that branch. So what did this actually make? A guessing game? Guessing game start. We don't have enough to do it, but we can code this part up yet so far. It's got a one guess game. You get one guess. So let's give it a shot. So we're going to need a number x, and we need an input or an integer y. And what number should we do our guessing game from? Anyone got any ideas? Should we do 1 to 10, 1 to 100? What? Oh, David left. My one person that likes to participate. All right, so let's do 100. So what we want to do for randoms is, this is the call for random. It'll generate a random number. In fact, let's just see it out. And I'm going to show you the other one, the maximum key. So if I do C at a random number, this generates a random number between 0 and rand max. Oh, I need a end line in there. So it generated 41 and the random number or the max is 32,762. I'm sorry, 767. I got 41 on the first try. And if I run it again, I got the same random number. That's fishy. What if I do it a few times? Well, the first one was 41, and now it's giving me some other numbers, but the first one was 41. Turns out it's not all that random, is it? Doesn't feel that random. So that's where time comes in. This wasn't random. Repeating it got 41 every try. Every time I ran. So it's not really random. The way we get around that is we need to seed it. This takes an input, and right now it's got a void input. We have no seed as an input of where to start the random numbers. So the way we get around that is, we'll do it below it. We do srand, which is like seed random. Then we're going to say time 0. This seeds the random function with the current time down to the, split second. So now I should be able to do it a few times. Actually, we already saw that having it the first time run. The first time ran, every other time was a 41. Now if we do it, it gave me an 8,039. So this is a way of generating random numbers between 0 and 32,767. I want to, okay, so this is between 0 and 32,767. We want 1 to 100. So the way we can go about, the way we go about doing that is if we do modulo 100, modulo 100 will now it keeps dividing by 100 until it gets down to a number, will now return a number between 0 and 99. I don't want to see it out because I'm just teaching right now. Let's say int x equals . And if I want it to be between 1 and 100, I have to add a 1 to it. And I think it's a little easier to read if you put the 1 in front. So I'm going to comment out this line. This does 1 to 100. So now we got to prompt the user. I guess I don't want to do it like that. I want to do that. And we'll do a cin for y, which I have not declared at that point. And then we had to do the loop. We had to check if it was too low. So the first thing was if y was less than x, you did a CR of you're too high or too low. And then the other option, so we'll do an else, which means I need a bracket before it. And in here, we had another if statement. If x was equal 5, we told it, we said, print out, you got it. And then the other thing on this one, the else on that one, was if, in this case, is the case where x was too high. See out, you're too high. So let's see, let's give it a try. Do we want to do 100? Wait, if x equals 5, if x equals y. There we go. Let's go ahead and give it a try. Let's do a smaller number. Let's do like 10. No, we'll leave it at 100 because I don't want to change all the notes. Well, smack dab in the middle, 50. I'm too high. And I apparently have an end line there that I didn't want because it looked funny, didn't it? So if I try it again, see if I can get it. Nope, I'm too low that time. So it's going through the trees and it's working, but I can't really like keep guessing until I get it. I think that's one of the later laps. But this will get you started, and that's a way to read the flow charts. So this is the start. This is taking action. The parallelogram is taking action. Rectangles are doing action that shows on the screen. And the diamonds are decision-making things. So that's worth checking out. What else did I want to cover today? Logical operators. I did not do logical operators yet. So I'm going to comment this out. And so now let's look at logical operators. And this is in 4-beat. So we're going to do and, or not. Okay. So the and statement. And test is the double ampersand. So let's put some values back in. Int a equals 1. Int b equals 2. So what we can do if a equals 1 and b equals 2. See how? Yep. A equals 1 and B equals 2. So it requires both effects to trigger. And I can show that to you by doing one that where we change the value. Let's say if A equals 2 and B equals 2, does this one trigger? That one does not trigger. So the and with the double ampersand requires both conditions to be met. Then we have the OR test. And these are double pipes. And for me, I have to hold down shift and it's the key above the enter key. This double pipes, which is the shift plus slash key above enter on my keyboard. May be different for yours. And I'll just copy this same thing down here and we'll change the and sign to the or. Okay. And I guess we should say, yep, A equals 2 or B equals 2. In fact, let's copy the first one too. See out or. Then we'll do and here. I guess we'll put the double, show the symbols in there. Now let's see what happens when we do the or stuff. I didn't change the wording on the one of them. Let me fix the wording. This should say or. So what's going on? We get to this one. It goes if A equals 1. I didn't change the damn sign. Fail. So if A equals 1 or B equals 2, it's going to print the line. And then we came down to the next one and checked for A equal to 2 or B equal to 2. It prints the line. And then we can do the scenario where it's not on either of them. And it didn't run that one. So neither condition was met. Damn it. Neither condition was met. A did not equal 2. B did not equal 3. So this did not run. So that's the or. And finally, not is directly related to the exclamation we did before for not equals. Is our exclamation point. And we can put it outside of a test. might require another parentheses. There we go. So what are we checking? A is greater than 1. Not A greater than 1 would be A is less than or equal to 1. So let's check that one. It doesn't matter where I put the zoom window, it's always in the damn way. So it printed it out because it was the opposite. A is greater than 1 was false. Because A was not A was set to 1. A was set to 1. So A greater than 1 is false, and the not changes it to true. And so it runs this. Why do we care about this? What if we wanted to do some math inequalities? Like, is negative 3 less than x less than 13? Can I do that in a statement? It doesn't like it. I gotta comment it out. C++ will not do compound inequalities. So what's really going on? Let's see if I can steal the screen real quick. So we had negative 3 less than x less than 13. On a number line, damn, zoom windows in the way again. On a number line, let's see, negative 3's there and 13's there. And that's this region right here, right? But it won't do it like that. I can only do like one test at a time. So like if I do, is negative 3 less than x? That's the same thing as is x greater than negative 3? It's like an alligator or Pac-Man chasing the x if you're uncomfortable with switching around the inequalities. So that would be, it's going from this, nope, it's a hollow point. Pointing completely in that direction. And then if I do the other part, x is less than 13. Let's make it less than or equal to. I'd fill in the dot that way, and it's less than. Which means I need to change that right there and just make that a hollow circle. Well, negative 3 is less than or x is less than or equal to 13. That's meshing up with this region right here, where both take effect. So for compound inequalities, we can do and. We'll do if x is greater than -3 and x is less than or equal to 13. We do our and operator. And while I'm over here on this Surface Pro, we're going to talk about the other one, what the OR is good for. So let's say we are solving x squared. Why is it going so slow on this? That should be a 0. We all know that if you were to solve that, you should have this as your answer. And when we say that out loud, x equals Jesus. Just take the pen already. Plus or minus 1. I'm done using that thing. Stop share there. It's got the or in it. That's the point I was going with. So let's take a look at using the or in there. So I had -3 less than or equal to x, or less than x less than or equal to 13. The way to code that up is if x is greater than -3 and if x is less than or equal to 13. See how it's in the range.
Share the screen.
Oh, yeah. Good looking out. And it doesn't like what I'm doing, so I must not have x declared. So let me assign x real quick. Let's go with 1. So that's checking that one. And then we can also do the one I was just saying about the square root. Does it solve x squared minus 1 equals 0? So we say x equals plus or minus 1. That's the same thing as saying, does x equal 1? Or does x equal -1? But we can't use the word or, we got to put in the double pipes. Let's see out. X is a solution to x squared minus 1.
Is there any reason why we can't use the word?
Because it doesn't take words like that. I mean, you might have there might be some IDEs that work, but they don't work on every IDE. Like, see, I don't like it. Or as a word is not programmed in. The double pipes are. That's why.
Okay.
Good question, though. Thank you for asking. Always need questions being asked. So, maybe I'll say something here that we're getting ready to start. Showing uses for and or. And I won't say X, I'll say X equals 1 is in the range. And X equals 1 is a solution. So, what happened? Why are you doing this? Oh, I don't have that. Why is it saying there's a problem? Oh, the problem is above it. There we go. There we go. All right, so this is doing the compound inequality. This is how we would write it. And so we checked, was X 1 in between it? Yes, 1 is between -3 and 13. Then I checked to see if it solved x squared minus 1 equals 0. And x equals 1 is a solution, so it solved, it met the condition. I could have just as easily used -1. By changing x to -1 there. And it's going to do the same thing. Because it solves both of them. X equals -1 is in the range between -3 and 13. X equals -1 is a solution to x squared minus 1 equals 0. Let's see. Well, maybe we can do that. Maybe that will allow more heat to go. Okay, I wanted to show you recursion. But it's already 5:45. Maybe I'll make a video for recursion and post it. And next time we meet, we can do some questions over it. So let's call that a wrap here. Do you guys have any questions on this stuff so far?
No, but are you gonna unlock the homework soon?
It should be unlocked.
Oh. And maybe you unlocked it today, I didn't see.
They're all lit up green.
Okay. I checked several days and it was always locked, so I guess
I want to
you
say I did it yesterday
yeah, okay.
because we hadn't gotten to the topic yet, so I hadn't opened it yet. I have next one. If you're working ahead, I have module 5 open too, though.
Okay.
I opened both. Ooh, there's some in here that we didn't need to do. I did not want to turn on all those. There we go. Okay, so I'll make a recursion video tomorrow morning. Post it. Adrian is with you guys Wednesday night. I have a meeting I got to be at. I will try to pop in when the meeting's over. In fact, I'll make it at 5:30 to our Wednesday meeting. And we can go over the recursion then. Or I can actually do recursion then at 5:30. What do you guys think?
I think the video's fine.
Okay. I'm gonna go over the recursion video then. So I'll make it tomorrow morning. Because my tablet needs some time to cool off. It does not want to write. All right, I will stop sharing and we will call this a wrap. Unless there's any other questions. Anything I didn't touch, Adrian, that you think I should have?
I think you did really good, especially with that ternary operator thing.
Thank you.
Yeah.
All right, well, that's it. I'll stop recording.